Solving linear equations. So solving is determining the value of a variable that will make an equation a true statement. So the general steps to solving are here. Distribute, then you're going to combine like terms, move all your variables to one side, constants to another, and then divide by the coefficient of the variable. Basically, what you're doing is you're doing the order of operations backwards. You're starting at the add and subtract and working backwards. You're undoing them bottom to top. So, example 1, 10 minus 5x equals 3 times x minus 4 minus 2 times x plus 7. So step 1 is we need to distribute. So that means we need to multiply 3 into both. So this becomes 3x minus 12. Then we're also going to distribute this minus 2 into both inside the parentheses. So negative 2 times x makes negative 2x. Negative 2 times 7 makes negative 14. Then the left-hand side just stays 10 minus 5x. Now, before we start moving things across the equal sign, let's clean up what we can. So I'm going to combine like terms. So on the left, I have a 10 and a negative 5x. These are not like terms because they both don't have an x. On the right-hand side, I have a 3x and a negative 2x that I can combine up to make 1x. And then negative 12 minus 14 makes negative 26. And then again, the left-hand side is just going to stay 10 minus 5x. Now that we have simplified the equation, now we need to get all the x's in one place. So I'm going to move the smaller x across. So this negative 5x is the smaller x. So I need to cancel it from this side and move it over to the right-hand side. So to cancel out a minus, we're going to add 5x to both sides. You got whatever you do to one side, you have to do to the other. So this becomes 10 equals 6x minus 26. So now we're going to move the minus 26. And again, the opposite of minus is adding. So we're going to add 26 to both sides. So this becomes 36 equals 6x. Now, to get the 6 and the x apart, 6 is being multiplied to x. So to undo multiplication, we're going to divide. So we get x equals 36 divided by 6 makes 6. Example 2, x minus 2 over 5 plus 5 equals 10. Now, we cannot get into this minus 2 up here because I have a division. But if you see that this plus 5 is not affected by this division, so let's get rid of that plus 5. So subtract 5 from both sides. X minus 2 all over 5 equals 5. Now again, we can't add 2 because of the division. So since both x and 2 are being divided by 5, I have to undo this division by 5. Well, to undo division, we multiply. So multiply by 5 on both sides. So this 5 and this denominator 5 will make a 1. So we get x minus 2 equals 5 times 5 on the right makes 25. And then now we can solve this by adding 2 to both sides of my equation. X equals 27. Example 3, 2 times 3x minus 6 equals 5 minus x plus 2. So step 1, I see parentheses, so I need to distribute before I can start moving stuff around. So this 2 gets multiplied in. So 2 times 3x makes 6x, 2 times negative 6 makes negative 12, equals. Now on the right, you have to be careful. This 5 is not being distributed. There's a minus in the middle of the 5 and the parenthesis. So the 5 is going to be dropped. What gets distributed is this little negative 1 out here in the front that we don't actually write. So negative 1 times x makes negative x, negative 1 times 2 makes negative 2. Now, combine what you can on each side. So 6x and minus 12, these are not like terms, so I'm just going to drop them both to the next step. 5 minus x minus 2. I can combine the 5 and the minus 2 to make 3. Now that I have everything as simple as possible, I'm going to start moving things across the equal sign. I'm going to move the smaller variable first. I always move variables first because your ultimate goal is to get x by itself. So negative x is the smallest, so I'm going to add x to move it. So this makes 7x minus 12 equals 3. Now I need to get rid of the minus 12 first. 7x equals 15. And now I need to get rid of the 7. So again, 7 and x are being multiplied, so I'm going to divide by 7 to get rid of it. So x is just simply equal to 15 over 7. They're not always whole numbers. They can result in fractions. Okay, so example 4. I only have 1x. So again, the coefficient is being multiplied, so I have to do that last. So to get rid of this plus 4, I need to subtract 4. Now, I'm going to write this as negative 6x on the top over 5. It's going to make your life a little bit simpler, because this x is really x over 1, and these are being multiplied. And remember, to multiply fractions, you just multiply straight across. 6 times x gave us the 6x, 5 times 1 gave us 5. So, and next, make sure this negative gets pulled to the top, that we don't figure out where to use it. Then negative 26 minus 4 makes negative 30. Now I have to get rid of this division before I can get to the numerator. So I can't get to here until I get rid of division by 5. So to get rid of division by 5, I'm going to multiply by 5 on both sides of the equation. So negative 6x equals negative 150. Now I can get rid of the negative 6 by dividing. Negative 150 divided by negative 6 makes a positive 25. Example 5. So again, I see parentheses, so I need to distribute to get rid of them. So 2 times x makes 2x. 2 times 7 makes 14. The right-hand side is just going to follow us along since there were no parentheses over there. Step 2 is combine what you can. So on the left, 2x and 14 do not have any like terms, so they just drop. 6x and negative 4x are like terms, so 6 minus 4 makes 2, plus 9. Okay, so now I need to get all of my variables on one side. So I'm going to subtract 2x from both sides of the equation, and now something weird is going to happen here. On the left, 2x minus 2x makes nothing, and on the right, 2x minus 2x also makes nothing. So all we're left with is 14 equals 9. We don't have any more variables to solve for. Here in this step, all of my variables canceled out to a 0. So this is one of those special solutions. So we have two options here. We're going to look at the resulting statement here and decide if it's true or false. So does 14 equal 9? Well, no. So this is false. So what that means is, that there is no solution. No matter what number we substitute in for x, 1, 5, negative 10, 130, doesn't matter. It's always going to result in a false statement, so there is no possible number for x that makes this true, which means there's no solution. Example 6. Negative 8x plus 3 minus 2x equals negative 6x plus 3 minus 4x. There are no parentheses, so I'm going to go ahead and combine like terms. So on the left, I can combine negative 8x and negative 2x to make negative 10x. Then on the right, I can combine negative 6x and negative 4x to make negative 10x. Now that everything's combined, we're going to move our variables. So I'm going to add 10x to both sides, and look what happens again. Negative 10x plus 10x makes 0, and then on the right-hand side, the same thing. But this time what we're left with is 3 equals 3. So again, all of our variables made 0, so there's no x left over to solve for. So we look at the resulting statement, 3 equals 3, and we decide, is this true or false? So 3 equals 3 is in fact true. 3 does equal itself. So that means that there are infinitely many solutions. Now this means that any number we plug in for x, 1, negative 8, 17, 130, will always give a true statement, so there's a number of possibilities of solutions that x can be. Another way we say this is we also call this, it has a solution of all real numbers. Both of these mean the same thing. Infinitely many solutions and all real numbers are exactly the same concept.